Okay, example 2. On this example, we're asked to verify again. So pretty much everything in chapter 2.2 is going to say, verify this, verify that. What does verify mean? It means you're going to have an equation with a left side and a right side. And you somehow want to make the left side look like the right side. The general rule is work with the more complicated side. For everything I think that we're going to do, the left side, you're going to be able to work with the left side. Sometimes they both look complicated, but we should always, in every problem, be able to work with the left side is the way that it's designed. Typically, you could work with either side. I could try to take this 2 secant squared x and do all the manipulating I can to make it look like this. But that's going to be hard. It's easier to take something complicated and piece it together. Again, look for opportunities to factor, add fractions, FOIL, conjugate, split a fraction. When I'm looking over here, what I see is I've got 2 pieces. This piece plus that piece. Over here on the right side, I just have 1 piece. There's no plus sign or anything. So when that's the case, when the left side has 2 pieces and the right side has 1, what I'm going to want to do is take my 2 pieces and add them together. So I'm going to try to add these fractions together so I end up with 1 piece. Now this one says 1 over 1 minus sine x. This is 1 over 1 plus sine x. What I need to remember is if I wanted to add 2 fractions, I got to get the bottoms the same. And if the bottoms aren't the same, even though they look close, they're not the same, what you got to do is take the bottom of this one, take the denominator here, and you're going to have to multiply it here and here. So I'm going to write, let's use a different color. I'm going to use red only if I'm using any of these identities. I'm going to put right here 1 plus sine x and 1 plus sine x. So I copied this denominator here and here, and then I'm going to take this denominator and put it here and here, which is 1 minus sine x and 1 minus sine x. All right, now over on the left side, 1 plus sine x times 1 just makes 1 plus sine x. So this ends up being 1 plus sine x over, what I notice now is 1 plus sine x and 1 minus sine x, these are actually conjugates. So I think it's probably going to be a good idea to go ahead and let's put them together. Let's go ahead and, remember when you FOIL a conjugate, when you do your FOIL, if they're conjugates, like a 1 plus sine x and a 1 minus sine x, you can kind of skip the O and the I because they always cancel out. So when you do F, you get 1, skip the O and the I, and then just do the L. Sine x times negative sine x makes negative sine squared x. Over here, the numerator just becomes 1 plus, let me get that right, that's actually 1 minus sine x. Got 1 times 1 minus sine x. And the bottom, if you FOIL it out, it should be the same as this. It should make 1 minus sine squared x. Remember, you're multiplying out 2 conjugates, 1 minus sine squared x. The bottom should be the same now. I'm going to go ahead and say equals that, 2 secant squared x. All right, so for my first step, I saw I had 2 fractions on the left. I want to get them together to be one thing. Keep in mind what the right side is. The right side is like your goal. I want to take the left side, and I want to make it look like the right side. Now that these 2 fractions have the same bottom, what I can do is I can put these 2 fractions together as one. And a lot of times, other than throwing markers, a lot of times what I'm going to do when I want to show that I know what I'm doing is I'm going to put 2 arrows and say, okay, these 2 fractions can combine into 1. Like this. And the bottom is just going to be 1 minus sine squared x. People often mess this up, but if you think simple, like middle school math, if you had 2/5 plus 4/5, you would combine that together to make, you combine the tops to make 6, and the bottom doesn't make 10. The bottom you just put a 5. It's fifths and fifths. So when it comes to the trig, and these crazy, crazy hard-looking fractions, it's just the bottom is 1 minus sine squared, the bottom is 1 minus sine squared. That allows you to combine them, so the bottom is 1 minus sine squared. The top is going to be 1 plus sine x. Thankfully, this is a plus sign. If this is a plus sign, then I can just go plus 1 minus sine x. If this is a minus right here, I would have to think of it like a minus 1, and I'd have to apply the minus over here. So it's like you have to distribute the minus. But if it's just a plus 1, it makes it real easy. Now let's look at what we got. This still equals 2 secant squared x. Our goal is to somehow get secant squared x, so 2 secant squared x actually. All right, so if you look at what we have, we got 1 plus sine x plus 1 minus sine x. It looks like sine x minus sine x, that just goes away. That's like sine x minus sine x is gone. So this actually crosses out. And the top starts to look like 1 plus 1, which is 2. So I'm going to go ahead and put that. The top becomes 2. And the bottom, while I'm at it, I don't need to take 2 steps to do this. The top just becomes 2. 1 minus sine squared x. If I use my sheet, there is no identity on here that says 1 minus sine squared x. But what I do have is the cosine squared x plus sine squared x plus cosine squared x equals 1. I'll just do it right here real small and show you. Sine squared x plus cosine squared x equals 1. That's one of my main identities. If I can manipulate this around so it looks like 1 minus sine squared x, I might be able to change this. Might be able to get rid of this. So using this identity, I could minus sine squared x. That crosses out, and I'll have cosine squared x equals 1 minus sine squared x. That right there is what I'm looking at. That's what this is. And what that does is it gives me permission to replace this, which is 2 pieces. 1 minus sine squared x is 2 pieces. 2 pieces, and I can replace it with 1 piece, just a cosine squared x. So what I'm going to do is go right here, and that bottom, this right here, I'm going to sub it out, and I'm going to sub in a cosine squared x. And over here, I'm going to put my 2 secant squared x. All right, and I should see that now it's getting close. Heck, I got a 2 here. I got a 2 here. I have a cosine squared here. Well, that's a secant squared x. But the good thing is cosines and secants are related. Cosine squareds and secant squareds, they're really related somehow. They can turn into each other. If we wanted to, what we will do next, and it depends if you want to take that extra step or not, you could pull the 2 off to the side. And so this will take 2 steps. Pull the 2 off to the side, and then this becomes 1 over cosine squared x equals 2 secant squared x. And then the last thing is this right here, using your identities, 1 over cosine squared will turn into secant squared. So this right here, I'm down at the bottom, so let's see, 2 secant squared x equals, and heck, that's it. I'm done. I wanted to make it look like 2 secant squared x, and I got it to look like 2 secant squared x. So it took me, what, 1, 2, 3, 4, 5 steps. And I had to justify every step of the way. So here's every step of the way what I did. First, we got the bottoms the same, added them together. Once the bottoms are the same, kind of multiply it out, added them together, the signs crossed out and left us with 1 and 1, which made 2. The bottom, we used our identities to make cosine squared. And then we pulled the 2 off so we could have 1 over cosine squared, which magically turns into secant squared x. And that pretty much sums up identity for example number 2. Make the left side look like the right side.